Well, you did it. Go ahead and congratulate yourself. You're sticking with the class. You're doing the work to learn the outcomes you need to either understand cybersecurity within your industry, within your future career, or to become a cybersecurity professional. And of course, to help you practice and learn the outcomes you need to successfully pass the ISC2 Certified in Cybersecurity Introductory Certification. So, Part 5, Chapter 3.0, Through the Hacker's Lens. Let's go ahead and look at attacks. Now, before we do that, for those of you that may be watching this, I do have an associated textbook that's part of a class that I teach at the college where I teach. If you would like a copy of that textbook, please let me know. I'm happy to send you one. All right. So let's go ahead and dive into our last section, finishing threats, vulnerabilities, and attacks. Well, with attacks. So trends in malware, as we talk about malware real quick, recent trends in malware, just to sort of finish that section off, is fileless malware. So this is malware that doesn't install into secondary memory. It operates in primary memory, in RAM, to evade detection, because a lot of times our spyware detection software, okay, is looking at files. It's looking at systems. It's looking for signatures, which are essentially identifiable code that identifies with a piece of malicious software. All right? Take that out, stick it in memory. Now suddenly we have a whole new challenge in that the malicious software is in memory and thus does not reside in secondary storage that is traditionally scanned. Okay? Polymorphic malware, continuously changing code to avoid detection. We'll see, the implementation of AI, more code being written, more complex malware being written that can change itself to keep from having an identifiable signature. So it may change itself in the case of a worm. It may change itself enough when it's propagated, each time it's propagated, so that it doesn't show up as the same malware on different nodes within our network. Okay? Add to that machine learning, developing smarter malware that adapts to environments, utilizing AI to write code, okay, that's going to be used for malicious purposes. We might fool large language models into helping us write code that we know we're going to combine together to do something malicious, right? Snowflake's example, staying updated with the latest trends and adopting defenses accordingly. So, attacks and techniques. And again, I'll remind you, these things all kind of overlap. Threats and attacks, they all go together, right? So an exploit is a particular attack that takes advantage of a system vulnerability, right? So the 0 days in Stuxnet were the exploit, right? For Snowflake experienced an exploit targeting a previously known vulnerability in their customer relationship management software. Again, woof! That software is unsecure, huh? No offense to you customer relationship management software companies. Allowing attackers to gain unauthorized access to sensitive client information. So maybe through the system, they were able to exploit a vulnerability that gave them access to the database associated with the front-end CRM. Boom, they start, piling that data through command and control. They start offloading that data from the network, putting it on the dark web, doing something with it. Maybe in a lot of cases just saying, look, we have your data and we're going to release it if you don't, whatever, right? Mitigation, so quickly patch those vulnerabilities. It's amazing how many times there's a vulnerability. Even today, there's a vulnerability out that doesn't get patched for a week. And a week is all the time that's needed for a malware virus writer to write some malware that takes advantage of that, get that out, and get those attacks going before patches are given. So a fragment attack is an attacker fragments traffic so that the system is unable to reassemble data packets correctly. So we basically send a bunch of stuff, right? It would be like me communicating with you, you're a computer, and suddenly 6 people are on this recording, all talking to you at once. Okay? So, Snowflake's network team detected fragmented attack, that overwhelmed their systems. How did they mitigate it? They, did more stringent packet filtering. They defined some packet rules around fragmentation, around what we're going to talk about next, oversized packets, etc. Right? Maybe upgraded hardware so that more analysis could be done. Oversized packets is another packet attack. This time we're sending packets larger than expected. So here we see maybe, in our diagram here, a regular packet, and then here's some packets, that are 3 times as large, 4 times as large, 10 times as large, all hitting the same network. So in this case, Snowflake servers were targeted with an oversized packet attack, leading to service disruptions. So the computer couldn't respond. It's like, forget it, I'm done, I'm out. Shut down. No one can get to the website. No one can get to an employee portal. No one can get to, a financial portal. Who knows, right? No one can order on Amazon. Can you imagine how many of these attacks happen to Amazon a day? And how many people it takes to protect their network? How much technology in the millions, if not hundreds, definitely hundreds of millions of dollars they spend on cybersecurity defense mechanisms. So, configured firewalls, for packet reassembly, validation rules, not accepting those large packets, so dumping those off, keeping within a certain frame size, for example. So, as you advance your career, you'll learn from like Cisco Cyber Ops the details of this information. So man in the middle is, as it sounds, an adversary intercepts and alters data traveling between a user and a system. So remember we talked about IP address spoofing? That's part of a man in the middle attack. They use an acceptable or an approved IP address, or they make their traffic look like a legitimate node on the network. Okay, and thus sending their packets instead. So they would, get the packets legitimately because they're in the middle from the node, and then they modify them to send modified or, damaging packets with malware, whatever the case may be. Okay, so end-to-end encryption. That way, if there is a man in the middle, we can't look at the packets, can't modify the packets. Thus, man in the middle becomes way more difficult, right? That all software updates are verified. If software's updates are downloaded from the web, every time I download Kali Linux, I look at that hash. I make sure that hash is exactly what I expect it to be, that some node is not giving me a false version of Kali that has, say, a backdoor. Okay, Smurf attack, couldn't help but use this picture, right? Is a type of denial service attack that exploits weaknesses in those IP protocols, okay, to flood a target network with traffic from spoofed IP addresses, as we discussed. So, in the case of Snowflake, Snowflake's network was hit by a Smurf attack, leading to significant service disruptions. A lot of times, these attacks, denial of service attacks, they really are about service disruptions, where malware is about gaining access, whether it be command and control, whether it be malicious activity, such as encrypting files for malware, stealing people's data, screenshots, keystrokes, websites they're visiting. That's really huge, right? So, employed IP address filtering and disable IP-directed broadcasts to mitigate attacks so that broadcast IPs can't be used in a means of attacking a system. So that brings us to a DOS attack versus a DDoS attack. Okay, so a DOS attack is a denial of service attack, a malicious attempt to disrupt normal traffic, right, of targeted servers or a service or whatever. That could be targeting, an ISP in Bend and flooding their network, flooding their firewalls, on the front end so that people can't use the internet, for example. Flooding a Netflix server might be another example, so people can't watch whatever controversial movie is out now. Could be hacktivists, for example, right? So with a DOS attack, what I'm showing in this graphic is it tends to be a single node that is attacking, right, the target. Okay, so that is a DOS attack. Now, typically what you see is distributed denial of service attacks, and we'll use this image a little bit here. So similar to a DOS attack, but it involves multiple compromise. So here's all the compromise. They become the bots of the botnet, right, that the hacker is controlling, command and control, to go after a target. And in this case, whatever the target is, in the case of Snowflake, targeted by a DOS attack that overwhelmed their web servers with traffic from thousands of compromised devices. So maybe that's the web interface where people are gaining access to their cloud services that Snowflake is hosting. Thus, they can't get on their cloud services. They can't do any work. And we are successful with our botnet. So, supply chain attacks. So, when we talk about the target attack, and if you do more research on the target attack, that came through an HVAC vendor who had access to the system, right, so that they could see what stores they needed to service, what was wrong with HVAC, what was right with HVAC, changing, temperatures seasonally, whatever the case may be. And it was through that third-party vendor, the HVAC vendor, that had a link that gave people access to get that personal data, those credit cards, personal identifiable information of Target's customers. Target being the retail supply store, not a Target, if you will. So, a company's third-party vendors, that's the key here, okay? So SolarWinds, similar type of thing. Snowflake discovered that a trusted software vendor had been compromised, allowing attackers to insert malware into software updates. Then they go ahead, they download the software, and boom, there we are. Where do we see this on a personal level? Typically on our phone. If you start looking at news and getting news and finding and researching cybersecurity, you're going to get more news. A recent news that I got, was that there was a bunch of different software packages that had snuck their way past the Google security team onto the Google Play Store that look like legitimate apps that ended up having malicious code put into them. So this could be an app that everybody's using, say TikTok, right? And an update comes down for the TikTok app, and it's got malicious software. Somebody's gone in, they've hacked into TikTok, they've integrated their malicious software into the source code that operates TikTok. Now it's on our machine. Maybe they're just tracking us. Maybe they're using our phones as a botnet for another attack. And maybe and eventually ransomware. So keep that in mind. Keep that antivirus. Don't download apps that aren't legitimate. If you download an app and it's not something you're going to use, reduce the attack vector on your phone, get rid of the app, right? It's like when I first get a computer and it's got all that bloatware, I wipe it out, I reinstall without the bloatware. Okay, I bought the computer. I don't need Dell making money on me by giving me apps I'll never use that take up space on my drive. So attacks and techniques 3.7 is a SQL injection. So as you can see here, this attacker is creating code that takes advantage of a SQL statement that is incorrectly written that allows for space or data input, right, that is not intended. Modifying that query maybe in a way that gives people access to the data. Okay, so code injection technique is basically what it is. This time though with SQL statements within a database. Pretty typical. So Snowflake's public facing website experiences SQL injection. For all of you that don't know, that may be new, most websites today, are managed by a back-end database. So MySQL, right? In the case of small companies. So all of that data is stored, it's mined, it's protected, all that good stuff. But if there's vulnerabilities in there, I can go get that data by looking like a legitimate SQL query when in fact I'm not. Okay? Patching vulnerable code is huge. Again, there's been SQL injections where people haven't updated their SQL servers and their databases because they're afraid something might go wrong for years, and thus leaving a huge attack vector for people to find. We'll end with just a quick reminder of phishing. Phishing is really standard. There's a ton of it going on, right? Tricking users into providing sensitive information. This comes back to train your users, and train them again, and then test them. Send them those phishing things that they're apt to click on. Are they mousing over the URL? Are they checking the link? And most importantly, are they notifying you if they're getting some fraudulent email so that you can go ahead and block that for the rest of the users? Thus, someone who might click on it won't have the opportunity to do so. Again, through email filtering solutions. That takes us to the end, folks, of Chapter 3. We'll see you for Chapter 4. Chapter 4 is titled Enter the Empire, Passwords, Authentication, and Authorization. So we'll look at those 3 topics around the ISC2, as well as additional information you should know to have a good foundation in the basics of cybersecurity. Until then, have a great day and happy studying.